This is the age of the universe, approximately 13.8 billion years old. And we only need basic arithmetics to calculate this. No calculus needed. Calculating the approximate age of the universe is as easy as opening a jar of jelly. How is this possible? To understand that, we have to jump back in time a little, almost 100 years, into the year 1929. Edwin Hubble was chilling at the Mount Wilson Observatory looking at distant galaxies. He was interested in their distance and their velocity, so he measured it, and he got incredible results. Galaxies are moving away from us. Each galaxy he found was moving away from us, and even crazier, the further away they were, the faster they were moving away from us. Fascinated by this discovery, he put all his data into a graph. He plotted the velocity of the galaxies against their distance, and he found a linear relationship. Both the velocity and the distance from us were connected via a constant factor. This constant factor is nowadays known as the Hubble constant. Its value is around 70 kilometers per second per megaparsec. What does this value tell us? First, we should clarify what a megaparsec is. A parsec is an astronomical unit for distance from a time when parallaxes and trigonometry have been used to measure the distance between us and the stars in the sky. Transforming a parsec to a more convenient unit, we would get 3.26 light years. A kiloparsec is 1000 parsec and therefore 3260 light years. And a megaparsec is 1 million parsec, which is equal to 3.26 million light years. Now back to the Hubble constant. 70 kilometers per second per megaparsec means that a galaxy at a distance of 1 megaparsec is moving away from us with a speed of 70 kilometers per second. A galaxy at a distance of 10 megaparsec would move away with 700 kilometers per second from us. And a galaxy 100 megaparsec away from us would already fly at a crazy speed of 7,000 kilometers per second. How can we interpret those data? What is it that makes all the galaxies run away from us? Is it the galaxies themselves? Or is it something else? Spoiler, it's something else. It's space. Space is expanding. This is one of the craziest discoveries of the last century. But let's jump back to our original question, how to calculate the age of the universe. If space is expanding and therefore dragging galaxies away from each other, there must have been a time in which they have been closer, so close that no space was in between them anymore. A time when all of the universe was pressed into an infinitely small point, the singularity. And then, the Big Bang. And to determine when this time was, we're using Hubble's observations. So the data tell us that galaxies move away from us with an increasing speed of 70 kilometers per second every megaparsec. The velocity of a galaxy at a distance d from us is the Hubble constant multiplied by the distance d. At the same time, the velocity is defined as the distance traveled divided by the time needed to travel that distance. Here we assume that the expansion of space has been happening at a constant rate in the past. So Hubble times distance is equal to distance over time. We can drop the distances and we will find out that the time is 1 over Hubble. The time the galaxies needed to travel from us to where they are now is the inverse of the Hubble constant. We can easily calculate the age of the universe simply by inverting the Hubble constant. We just need to play a little bit with the units. First, we transform megaparsec to kilometers. 1 megaparsec is equal to 3.26 million light years. This is 3.26 times 10 to the power of 6 times. Now we convert the light years into kilometers, which is 9.461 times 10 to the power of 12 kilometers. And this eventually will give us 30.842 times 10 to the power of 18 kilometers. Now we can invert the Hubble constant, so we have 1/70 kilometers per second per megaparsec. So in the end we divide 1 megaparsec by 70, and this is the amount of seconds that we get, and it's 4.4 times 10 to the power of 17 seconds. Now we just have to turn the seconds into years, and finally we have it. The age of the universe, 13.95 billion years. Amazing! We got really close to the official value. What does the official value have that we don't? Well, it takes into account that the Hubble constant was not constant at all times of the universe. It heavily depended on the size of the universe and the amount of dark energy, dark matter, normal matter, and light floating around. Calculating this will require some calculus though. We can do that in another video. Let me know in the comments if you would like to see that. And if you like that video, please be so kind and leave a like. This will help me a lot with the algorithm. And yes, I hope to see you in the next video. Thanks for staying with me. Goodbye, my fellow path integrator.